Hello and welcome to miningdingo.com.au. I'm Xavier Hill and this is the first in our Mastermine podcast series. I'm pleased to have Brendan Parker from Advanced Mine Production Systems with us. Hello Brendan.
How are you, Xav? So a bit about me, mining engineer, focused mainly in underground, and I'm the principal engineer at Advanced Mining Production Systems. More info at advancedmps.com.au. But yeah, good to be here today, and thanks for getting us involved with these podcasts.
No, it's great to have you on board, Brendan. It's often a big complaint or a big issue on mine sites is drill and blast and trying to extract more efficiency from the whole process. So it's great to have companies like you on board because it's a skill set that many people are looking for information on. So what I want to cover today first is the whole drill and blast process, and that starts at the reserving stage. So we'll start at reserving, and first we'll get into what factors we use in the reserving process and how you go about applying them.
So reserving is fairly important just so we can make sure that we're pulling out economical ore. We're not throwing money away. So a few things to think about. The minimum mining width, so what the machines that you've actually got on site and what they're capable of doing, and also the size of the ore body. Generally, a lot of sites that use long hole open stoping methods are trying to be about 1.5 meters wide, down to some get down to about 0.7 if they're lucky, if they've got really good ground.
0.7, impressive.
Yeah, so there's a few other factors in there, and some mines can't do that because of their ground conditions.
Any other factors we apply around in the actual scheduling process?
Yeah, I mean, it's I suppose in sequencing stuff, it's important to try and optimise the number of working areas you've got. So whether you take into account fill areas where you're either paste filling or backfilling, you need to have drilling areas, you need to have areas where you're actually charging, others where you're bogging. So there's a fair few areas that you actually need to maintain that ore source. Mm-hmm. So that's sort of optimising your working areas.
Yep.
Some of the other things to consider is chatting to the geotechs and that about structures and considering stress distribution and how that may impact on any of your sequencing sort of stuff.
Yep. So it's interesting you mentioned geotech because a lot of sites I've seen, you'll have the same hydraulic radius for stopes that are 200 metres below surface with stopes that are 800 metres below surface, when clearly the stress conditions are far different. So what are we looking at when we get a geotech's report and the geotechnical inputs that go into the reserving process? What are some of the critical analysis we need to do to make sure that we're getting a not too conservative answer, yet obviously still mining things safely and effectively?
I reckon the big one for engineers is to question what the geotechs say. They tend to be fairly conservative with all sorts of things, so it's not necessarily doubting their results, but actually questioning them and finding out their reasonings behind things.
Yep.
Just to give you a better understanding of why they've given you that HR or those limitations on your stopes.
Yep.
And
when we go through that geotechnical data, I mean, clearly they're going to have their rationale. What are some of the options we have to present them with to around the calibration of their models? For example, the importance of the reconciliation data and gathering that data, but not just gathering, but actually turning it into real information.
Yeah, so historical data is fairly important to have, I think. So really looking at what you've done in the past, mm-hmm. What your reconciliations are saying. So are your stopes performing really well? Mm-hmm. Can we push the HR out a little bit and have some longer stopes?
Yep.
Or are they performing poorly and do we have to bring them in a bit more?
Yep.
Also thinking about the vertical interaction of levels, so leaving pillars and things like that. Best thing is to just communicate with geotechs, geologists, everyone on site and actually get the best information from them.
Yep.
I know engineers and geos and all the other departments sort of seem to not get along that well, but we've got to suck it up and find out what they know, because they're the experts in the field on site.
No, absolutely, Brennan. Okay, and in the reserving process, and obviously the scheduling is part of that, what are some of the typical rates you can expect on your drilling equipment, on typical sort of underground drilling equipment, and realistic utilisation and availability factors?
I think the best things to think about there are the size of your drill holes, and whether they're in a narrow vein or a bulk sort of mining method.
Yep.
Most drills you'd expect they'd be getting between 100 and 200 metres a shift drilling. It does depend on that hole size, and if narrow veins are a lot more labour intensive, so there might be more hole cleaning. They've got to move a lot more. Compared to a bulk mining method where your big rigs sit there, he drills a fan of rings, doesn't have to move, and he's just got to change bits. But generally they're also drilling larger holes.
Yep.
But 100 to 200 metres a shift is pretty good, and utilisation is normally pretty good if they're just sitting there. I mean, most rigs are fairly reliable these days.
Yeah. Okay. All right. So one of the big questions that I think a lot of people out there are going to have is around opening up a slot for underground mining. How do we create that first void to fire the rest of the stope into? It's often a black art. Lots of people have different opinions on how all this is done. Ideally, you just go in and raise bore everything, or a few years ago you go and air leg them. But when operations are looking for efficiency, sometimes you're not always afforded the luxury of just getting a raised bore rig to come and do everything, or you may not have top access. So what are some of the ideas around and your thoughts around slotting and how you go about doing it?
Again, it comes down to the mine. If you've got top and bottom access, what your ground conditions are like, that sort of stuff. But box holing is always a good option, but it's also the most expensive. So with sites trying to cut as much money as possible, it's generally management won't actually let you do that. So long hole rises have been sort of the common slotting method in the past. That's normally a pretty good method. Top and bottom axis, you still, if you're able to pull it through slowly, then you've got a bit more chance of pulling it through.
Using vertical crater retreat.
Rather than doing a one-shot wonder. Or a blind rise. It's normally not the best.
No, I've seen lots of issues with those one-shot wonders. Is there any tips around one-shot wonders you can give how to improve their ability to pull? Because you got any ideas around void ratios in the burn, or anything we can do to prime a location in the slot, etc., to try and improve our chances of pulling a slot?
Whenever I go to a site and have a look at their drill and blast practices, one of the first questions is what rise pattern are you using, and does it work? Every site's different, so one rise pattern that works really well at one mine might not work well at another. So if it's working well, there's no point changing it. But if it's not, I think the key is looking at that void ratio, making sure that there's enough reamers and contingency. If there's a single shot hole sort of pattern, then the risk is probably a bit higher than having something where you've got a couple of shot holes. So just looking at those sort of patterns and looking at the burdens between the holes and your initial void, so making sure there's enough reamers in there for the first few holes to fire into. The other one to sort of think about is some ground's got a lot of structures in it and might be really soft, so you need to try and get that energy in there before it dissipates through the ground quickly. Whereas hard, brittle rock sort of breaks a lot easier, and they normally come out a lot easier. Updating
of reserve factors. So obviously there's a lot of factors we use when we're calculating our reserves. What's the importance of getting that reconciliation data, turning information, and then putting that information back through your newly created every time you do your reserving process?
Yeah, it's fairly important to use historical data to try and optimise your stopes going forward. So if you're not actually using any data that you've found out or whatever in previous stopes, then it's sort of a waste of time. You're not really optimising your operation to increase the revenues. So looking at those reconciliations and how your stopes performed is fairly important. So doing things like looking at standoff distances of your holes to your hanging walls and footwall.
Yeah.
Are they enough? Is it over breaking too much? Also looking at where the geotech structures lie in those stopes. So can we do anything differently around there? Do we need to put primers in different areas and things like that? So then that can go into planning the next stope to make sure that we fire it differently. Or we might need to use low impact explosives on some of the hanging wall holes to reduce that impact. So getting that info out of the reconciliation is fairly important, I think. And then putting that back into your next design certainly improves your efficiencies of your stope and hopefully reduce that dilution and increase your recoveries, which is what we're there to do, really.
Absolutely. And so are there any ways to, because it can be a laborious process, collating all that reconciliation data and putting it into information, what do you suggest? Do we just use basic Excel spreadsheets, or is there something else we can do around trying to speed up that process, I guess?
I suppose if you could just use an Excel spreadsheet, do some calculations and do a basic reconciliation and review of the stope, then that's a good start. Some mines like to get a lot more information that the geotechs then use to put back into their models and improve their calcs and things. So it depends what you want to get out of it. But just doing a review of what overbroke, what underbroke, what your dilutions were, what you'd planned to get out, and what you actually got out, so then you can reconcile against the block model and tell the geos that they're either doing a good job or need to sharpen the pencil. But no, it's fairly important to get that sort of information, I think, and get it back into the reserves.
So stope optimisations. So we've been given the resource. We've actually got to go in there and optimise these stopes. How do we go about doing it?
Well, I think the first point is getting people to do them in the first place. There's so many sites I go to that don't actually look at their financials and their tonnes and grade before they start drilling. So just doing a first pass, you use your minimum mining shapes, minimum mining width, run that through your stope or your level, whatever you're designing. Do a first pass tonnes and grade, work out what's below your cutoff and what's above your cutoff, as long as you know what your cutoff grades are. So quickly on cutoff grades, you need to put in all your costs and work out what actually makes money and what doesn't, including all your drilling and blasting and milling costs. And then working out if you need to leave any pillars or leave areas behind. And then, basically that's as easy as it is to optimise your stope, really.
And Brendan, what are some of the most common issues you see when you go to a new site?
They're normally fairly similar with most sites that you go to, but one of the main things that I see in mining in general is production engineers are normally straight out of uni. They may have got their underground time and they go straight into production. But production is actually where all the money's made. So we've got the least experienced people doing all the designs to extract the ore, and then they move on to development and planning and that sort of stuff. Yet they're not as important as production, I don't think. So I think where we like to help is to try and get some of that knowledge into production and optimise that area of the mine. The other one is cut-off grades. So a lot of mines don't have a good understanding of their costs and their cut-off grades. I like to try and get daily costs so we know how much we're actually spending each day and have a good understanding and handle of where our costs are going. Which can then be put into our cut-off grades, being for stopes, so what makes money and what doesn't. and also for development. So when geos actually stop a drive,
Yes.
rather than just mining for the sake of mining because there's a vein in the face or something, we need to actually look at, does it actually make money? Is it adding value to the mine?
Yeah.
And putting a few restraints on them a little bit rather than exploring with the development drive.
Yeah, the old 5x5 exploration hole.
Yeah.
Yeah, look, it's something that's always sort of befuddled me as well, is we spend all these tens, hundreds, sometimes even billions of dollars in exploration, all that capital to get a mine going, do all that development, etc. And then the bit that actually, all that's for naught if we're not pulling the stopes correctly. If they're not coming out and we don't get the ore, then it's all for naught. So it's such a critical function. It's why. It's great to see organisations like AMPS that are out there and can actually help a lot of these junior engineers.
Yeah, it's sometimes really hard with some companies because they do have financial obligations, so they're really just trying to get ounces and tonnes rather than actual ounces that make more, tonnes that make money. So it's a bit of a tough one because the politics of a mine site can be fairly strange to a young engineer that's not used to that higher level of management.
Yep.
But I think the key is just get an understanding of the company and what their sort of their aims are and what their targets are set on.
Yep.
They might need to keep the mill turning. I mean, they might need to just keep tonnes going through it. But always keep in mind that it's so important to look at the costs of mining a stope or development. And if it doesn't make money, like what's the point of mining it, really?
Exactly. All right, thanks for that. So now we'll move on. We've gone on, we've created our reserve. We're now getting into the production phase of our drill and blast process.